Hello everyone, we are back. Today we are going to be doing quadratics in one shot. Okay, everything about quadratics, completing the square, okay, finding the minimum points, maximum points of quadratics, plotting quadratics at that point, then modulus of quadratics, then there's going to be about discriminants and quadratic inequality. Okay, so let's get this. Okay, again, I'm going to be trying to cover this in as short time as possible. Last time it went to 45 minutes. Let's try doing this in 30 minutes today. Okay, let's start. Okay, so my name is Shamo Gupta. Stop whatever you're doing. Okay, grab a cup of coffee, stop playing around and watch this. Okay, let's have some fun. Now there's also simultaneous equations, which might be you also might learn simultaneous equations in this chapter. Okay, I'm going to skip simultaneous equations because those are easy things. Okay, they are in your normal extended maths also. Most of you can already do that. Okay, so I don't think there's any problem with simultaneous equations. Let's start with the first thing, which is completing the square. Okay, I'm going to start off with the first thing, which is completing the square. Let's start. Suppose I have something like this. I want you to expand this. I want you to expand this. Or let's take -7 actually. Let's take -7. I want you to expand this. You'll be like, okay, Shamo, very easy. We know a plus b squared is a squared plus b squared plus 2ab. So this becomes x squared plus 6x plus 9 minus 7. So x squared plus 6x plus 2. Very good. Now, this was expansion. What was this? Expansion. Expansion. Now, what if I want to go back the other way? What if I want to go like this? This will be called completing the square. This is called completing the square. That's basically what completing the square is. Okay? And the process of doing that is extremely simple. Okay? Understand this. I just want you to know a plus b squared is a squared plus b squared plus 2ab. We all know that. Okay? So, in this case, when we were expanding x plus 3 square minus 7, we were getting x square plus 6x plus 9 minus 7. So it became x square plus 6x plus 2. Now, if I want to go back the other way, let's go from x square plus 6x plus 2 to x plus 3 squared minus 7. Now, notice I want it to be in a square term. So I only want one x term. Like over here, we have only one x over here. Here we have x squared also and 6x also. We don't want that. We only want one x, but it can be in something squared. Okay, so let's see. You want to get 6x. You want to get 6x, but in something like this. Well, you can be thinking that, Shaman, how do we choose what goes inside? We know 3 should go inside. How do we choose? It could have been x plus 1 squared, blah 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 blah, and then plus. If you actually do this, you can do x plus 1 squared plus 4x plus 1. This is the same thing as well. But we don't want that. We don't want any x here. We want all the x, if any x, to be inside this. So what can we do? Well, it's simple. Okay. Remember, this is a squared plus b squared plus 2ab. So if we want a 6x here, we can have x plus 3 squared here. Because that will make this a squared plus b squared plus 2ab, 2 times x times 3, 6x. Remember here, we were multiplying by 2. X plus 3 squared, we were multiplying by 2 to get 6x. If you're working the other way around, just divide by 2, because afterwards it will multiply by 2 to give you 6. Afterwards, it will multiply by 2 to give you 6. That's the point. And then the outside number can be any number, any integer, provided it's not anything with x. Okay. So see what we have here. We have x squared plus 6x plus 9. Okay. We just wanted x squared plus 6x. X squared plus 6x was what we wanted to get. We got x squared plus 6x. Then we got a plus 9 extra. We got a plus 9 also. We did not want that plus 9. So just minus that 9 back, because x plus 9 minus 9 is the same as x. Okay. We wanted x squared plus 6x. In the process of wanting x squared plus 6x, we got x squared plus 6x plus 9. So just minus that 9 off. And then we have that plus 2 as usual. So it becomes x plus 3 squared minus 7. So the general rule of thumb is to divide this number with 2. So I got x plus 3 squared. The reason is because of the 2ab, it will multiply back to this. Or another way you could think about it is here you're multiplying by 2 because of the 2ab. When you're doing the reverse process, you divide it by 2. Okay, when you're doing the reverse process, you divide it by 2. Now, let's take another example. Okay, let's take let me think of something. Let's take x squared minus 2x plus 7. Okay, this can be written as x minus 1 squared. This will give me x squared minus 2x. Then there's a plus 1 because of this. I wanted x squared minus 2x. I got x squared minus 2x plus 1. So I minus that 1 off, and then I add the 7 and as usual. Simple, it gives me x minus 1 squared plus 6. Okay, now sometimes you have to be careful. You might have terms which have a 2x, squared. So for example, let's think of something random. 2x squared plus 6x minus 9. 2x squared plus 6x minus 9. Here, you have to be slightly careful. We want the coefficient of x squared to be 1. Coefficient means whatever numbers in front of the x squared. Here we have 2 as the coefficient. We want the coefficient to be 1. Now, Shamit, why do we want the coefficient to be 1? It's because a plus b squared, a has a coefficient. A is just a, b is just b. Okay, so it's a squared plus b squared. Here, it was x plus 3, we got x squared. If you don't want any coefficient like that, you'll put 2x here, you'll get 4x squared. Okay, then you'll be like, okay, Shamit, I can put root 2x. You can put root 2x, and then you can put plus 3 like this if you want. So it will become 2x squared, but then you won't be able to get 6x. It'll give you 6 root 2x. It'll give you 6 root 2x. Okay, so you have to be careful in this matter. It's best if the coefficient is 1, because if the coefficient is 1, it will be 2ab, and a will just be x. See over here, a is just x, a is just x. If a is just x, then 2b you can just divide by 2 easily. Here you can't divide by 2 because a is root 2x. So that's why you were getting 6 root 2x. Okay, so that's the logic behind it. Again, we are being a bit quick, so we are not going to go too much into the logic. Now, what can you do then? Well, you can factorize the 2 out into something like this, and then complete the square. Or you'll be like, Shaman, why didn't you take the 9 inside? Sure, bro, take inside. Also can. When you complete the square from here, I'll do it very quickly. I'll add another bracket. This will become x plus 3 over 2 squared. Now I've added 3 over 2 squared, which is 9 over 4. I minus 9 over 4, but that 9 over 4 is multiplied with the 2. Because over here, I want x squared plus 3x. So this is x squared plus 3x. Multiplied with the 2, multiplied with the 2. Then the minus sign is outside. Because here, x squared plus 3x is multiplied with the 2, minus 9 is not. So here, x squared plus 3x, and then minus 9 over 4, that gives you x squared plus 3x. This should also be multiplied by 2, and the minus 9 should not. Because, hello, this is x squared plus 3x. This is also x squared plus 3x. This was plus 9 over 4, minus 9 over 4. So this is also x squared plus 3x. So this will be multiplied by 2. So that will give you 2 x plus 3 over 2 squared. If you want to send this outside, it will become minus 9 over 2, because 2 times minus 9 over 4, and then minus 9. So this will become 2 x plus 3 over 2 squared. Then this will be minus 9 over 2 minus 27 over 2. Yes. Okay. Oh, you could have done the same thing here. Let's use a different color. This would have been x plus 3 over 2 squared minus 9 over 4. And the minus 9 over 2 is also multiplied with the 2. So it will become 2 x plus 3 over 2 squared minus 27 over 4, which is also multiplied with the 2. If you want to write it in this way, you can. This is the same as 2 x plus 3 over 2 squared. Then if you want to send this, if you don't want it to multiply with the 2, if you want to expand this like this, then the minus 27 over 4 multiplies with the 2 to become minus 27 over 2. Okay, that's completing the square in a nutshell for you. Now, why is completing the square helpful? First thing is it helps you find the inverse of a function. For example, let's take the example of x squared plus 6x plus 2. If you want to find the inverse of x squared plus 6x plus 2, or if you want to make it a subject, you just got x plus 3 squared plus 1. No, minus 9 plus 2, so minus 7. Minus 7. this is fx. You can easily find the inverse from this now. Okay, with this you couldn't have found the inverse. Another very important application is in the drawing of graphs. Now you'll be like, how does in the drawing of graph matter? So let's look at this graph. How will we sketch it? Okay, you'll be like, okay, we need 2 points. We need the x-intercept and we need the y-intercept. Okay, x-intercept is when y is equal to 0. Let's quickly, I'm going to mentally calculate what that's going to be. That's not going to be a very good value. It will be when y is equal to 0. So it will become x plus 3 will need to be, x plus 3 will need to be plus or minus square root of 7, then minus 3. So it will be not very good value, but it's okay. Then the y-intercept will be -7. Okay, so if you want to see how this graph will look like, it will be something like the x-intercept will be plus minus square root of 7 minus 3 square root of 7 minus 3 x plus 3 squared minus 9. The y-intercept is going to be positive 2. Sorry, yeah, now it makes sense. I was thinking, how can the y-intercept be -7? The y-intercept is going to be positive 2 because when x is 0, this will be 9 minus 7, which is 2. Sorry, I'm human. So this graph is going to be something like this, where this is 2. This will become root 7 minus 3. This will become negative root 7 minus 3. Fair enough. Now, here's the question. What's this point going to be? Whoa, we have to find this point also? Yes, you have to find this point also. Notice this point is actually the minimum point in the graph. Every other point is above this. This point is the minimum point in this graph. We have the function. We just have to find the range of this function. We just have to find the range of this function. We just have to find the range of this function. Okay, what do you think is the lowest value this function can have? Lowest value this function can have? Well, if I take any value of x, which is positive, it's going to increase this number. If I take 1, it's going to be 1 plus 3 squared, which is going to be a positive number. If I take -1, it's going to be -1 plus 3 squared, which is going to be a positive number. If I take -5, it's still going to be a positive number because any number square is still positive. But if I make this bracket equals to 0, if I make x plus 3 equals to 0, and if I get x equals to -3, this whole thing will become 0. And that's the lowest value it can have. Because x plus 3 squared, any value I put which is not 0, it'll give me something positive. Any value, except for -3, because it'll give me 0. So means this is the lowest value x plus 3 squared can have, means the lowest value x plus 3 squared minus 7 can have will be -7, the lowest y value. And at what x value will it happen? At -3. So -3, -7 is the minimum point. And a general rule of thumb, this was a logical understanding of it, but the general rule of thumb will be that this will be the y value, and this inside thing, if you make it equal to 0, it will be the x value. Okay, understood? Okay, the same thing could have been done if it was a maximum point. Okay, if it was a maximum point, the only difference would have been that you would have gotten a negative outside. Okay, so you want an example? Okay, let's take the negative of this. Okay, fx equals to minus x squared plus 6x minus 2. Fx equals to minus x squared minus 6x minus 2. Okay, I'm taking the negative of the whole thing. Let's factorize the negative out. Negative x squared plus 6x plus 2. Okay, I'm just going to copy paste our result from this, x plus 3 squared minus 7. So it's going to be the negative of x plus 3 squared minus 7, which is negative of x plus 3 squared plus 7. Nothing's going to change. The only difference is this is plus 7. But the lowest point will still be when x plus 3 is equal to 0. So when x equals to -3. But this time it will be the highest point. It will be the highest point, not the lowest point, because any value of this will be positive. And if this value is positive, negative of something positive plus 7 won't be the lowest point. Oh, sorry, won't be the highest point. Suppose this is -2. -2 plus 7 is 5. Or any number. X plus 3 squared will be 2, yeah? But because of the negative, this negative, so that will mean that every value will be lower than 7, except when x is equal to -3, it will be 7. So again, the same thing, 7 is the highest value. And this thing, inside thing, just make it equal to 0. So x plus 3 equals to 0. x equals to -3, and so on. So -3, 7 will be your highest point. Again, you can find your intercepts, your roots the same way. Okay, -2 will be the y-intercept, and you can find the x-intercepts in a similar manner. Okay, that's all which is to do with this. Now, there's one question which they ask about the modulus of quadratic functions. Again, this is very easy. Suppose a quadratic function was like this. Dude, very simple. Just reflect the negative side onto the positive side. Okay. The only thing which they sometimes might do is they might ask you to find this coordinate. Okay. So suppose this coordinate, like how we previously got, was let's use this example. It was -3, -7. This was -3, -7. If you modulus it, this will become -3, +7. That's it. So the modulus of this graph, x squared plus 6x minus 2, it look like something like this. And this point will be -3, +7. You just have to reflect the negative part of it on the reflection over the x-axis. Okay. If you're not sure why it works like that, or not exactly sure how it works, you should check out my video on functions. Okay. You can just check the channel. There's a video on functions also, and then you can skip to the modulus part. But if you just want to know very briefly as a recap, you reflect the negative part over the x-axis. So this part gets reflected. This becomes -3, 7. Okay. And if it was a opposite graph like this, it gets reflected like this. Okay. Notice in the first graph, if the graph was a positive graph, we are getting something like this. And the second graph, which is a negative graph, it was a negative graph flipped, we are also getting something like this. So that means that two different graphs can give us the same modulus graph. Okay, they might ask questions on that, because I remember one time there was a question on that. We don't have that much time to go into so much detail here. Again, I go into this much detail in my tuitions, but I want to make sure the video isn't too long for you guys as well. So I will skip that. I'll skip that part. I'll skip some examples of it for now, but as you can see, this is the general idea of it. You can have two different quadratic functions, but their modulus graph is the same, provided they are reflections of each other. Okay, so provided that this was fx and this was negative fx, then their modulus will be the same. Okay, I hope you understood that. Examples and all I give in my tuition classes. I don't have enough time for it right now. You could join those if you want. I'll pin it in the description. Okay, but right now let's move on. Let's move on to this thing called quadratic inequality. Okay, first thing, I just want to clear your basic inequality first in 2 minutes. Okay, suppose 2x minus 3 is greater than 7. You'll be like, sure, 2x greater than 10, x greater than 5. No problem here. Now I have a question. Suppose it's minus 2x minus 3 greater than 7. You'll be like, okay, minus 2x greater than 10, x greater than minus 5. No, this is wrong. This is correct. This is wrong. Huh? Oh, Shamo, what is this? This was correct. The left side was correct. This is wrong. Why? The reason is, whenever you divide or multiply with a negative number, the sign must flip. So if it's negative 2x greater than 10, it's not going to be x greater than 10 over negative 2. So it's not going to be x greater than negative 5. No, it will be if minus 2x is greater than 10. If it's a negative side, the sign flips. So x will be lesser than 10 over negative 2. So x will be lesser than negative 5. Again, why this happens, we don't have that much time. But just know that the sign flips. The sign flips. You can test out and see. Okay, test any value. So we've said this is wrong and this is correct, right? Take any value which is greater than negative 5. Take negative 4. Negative 2 times negative 4 is 8. 8 is not bigger than 10, which provides evidence that this is wrong. Take x lesser than negative 5. Take negative 6, for example. Negative 2 times negative 6 is what? 12. 12 is bigger than 10. So evidence-wise, this is correct. Okay, so be careful. Whenever there's a negative sign, the sign flips. Now let's go to quadratic inequality. Let's say I have a quadratic which goes by x squared minus 8x plus 15. Or how about I take yeah, that was good. X squared minus 8x plus 15. and I want to find values for which this is positive. Now I know the graph will look something like, I'm not sure how it will look on the y-axis. Let me see. It looks something like this, the graph. Okay. So they've asked me for the values where the graph is positive, means everything except this, everything except this. So to solve it in terms of inequality. So how do we do this? Now, the first thing is, how about we factorize this? X minus 5, x minus 3 is bigger than 0. Now, here's the technique. This is the technique I use. Sketch a graph, but only plot the x-axis. Don't plot the y-axis. Why don't we plot the y-axis? We don't want to get confused where the minimum point will be. Okay, because see, we know the roots of this graph will be 5 and 3. So it will be something like this, hopefully, where this is 3 and this is 5. But many times you don't want to confuse with the y-axis because you don't know which exact. It could have been in the top left, top right, bottom left, bottom right. You don't know. So just stick with the x-axis. It's easier also. And you know it's going to be a positive graph because this is the coefficient is positive 1. So the graph is going to be something like this. Okay, and we know that this value is going to be 3. This value is going to be 5. This is the x-axis. Yeah, this black line is the x-axis. The x-axis is basically y is equal to 0. The x-axis is basically just called y is equal to 0. So anything which is above the x-axis is positive. Anything which is below the x-axis is negative. So you can see all this value which is lesser than 3, x lesser than 3, and all values which are bigger than 5, x bigger than 5 are positive. These values. Remember, I'm shading on the line. Okay, many people shade regions like this. No, shading on the line is more accurate because those are the values you want. Okay. Now, one thing I want to really warn you, if it's x minus 5, x minus 3, please use this graphical method I've taught you. Some students, and this has happened with my students so many times, and you know, when I give them tuitions, it's happened so many times. Please don't make this mistake. I'm warning you. I have explained this over 1,000 times to them. I can't do that to you, but this is sometimes what they do. No, this does not work. This does not work. This only works if this was equals to, if x minus 5, x minus 3 equals to 0, then you can take it case by case. X minus 5 equals to 0. X minus 3 equals to 0. Then you can. If it's an inequality, then you can't. Then you have to do this method. Please. Okay. You have to do this method. Okay. I hope that was understood. If there's a negative inequality, nothing matters. If it was a negative graph, suppose this was negative, it would have been something like this, and then you can find it the similar way. You just need to find the roots. Okay. You don't need to know the maximum point. You don't need to know anything. You just need to know the x-intercepts for that. And you need to know a little bit of logic. Okay. You need to know a little bit of logic. Now, let's move on. Let's move on to this thing called real and distinct roots, blah, 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 blah. Okay. Now, we know that the quadratic formula is negative b plus or minus square root of b square minus 4ac over 2a for quadratics. Okay. This is the quadratic formula. We are dealing with quadratics, so we'll deal with the quadratic formula only. Okay. Notice this is a plus minus. Means there can be two answers. One where you use the plus, one where you use the minus. But here's the catch. Remember, even in functions, we discussed that square roots can never be negative. Square roots can be 0. Square roots can never be negative in our syllabus. Okay. If square roots are negative, which by the way they can, it's just not in our syllabus. For example, square roots can be negative. Square root of negative 5 is the same thing as square root of 5i, which is I is the complex number. It's something called complex numbers, which is beyond our syllabus. Okay. So when we talk about roots, you know, quadratic formula gives us the roots, right? So when we talk about roots, we talk about real roots or complex roots. So if anything in a discriminant is negative, we call it complex roots, and complex roots are not in our syllabus. Okay. So suppose the discriminant is negative. So we have complex roots, right? But because that's not in our syllabus, we just say that there are no real roots. Because they are not real. They are not real roots. By the way, real doesn't mean that they have to exist. Okay. That doesn't mean that complex roots are unreal. But that's just the name. Okay. So there are no real roots if the discriminant is negative. And if the discriminant is equal to 0, what if the discriminant equals to 0? Then check. This will become negative b plus or minus 0 over 2a, which means it's just negative b over 2a, which means you have only one root. But here's the thing, okay? Quadratics always have two roots. They always have two roots. This is a property. Linear functions always have one root. Quadratics always have two roots. Cubics always have three roots. But here we are getting only one root. So we call that a repeated root. Basically, it has two roots, but those two roots are the same. We call it a repeated root. I know it sounds silly, but that's how it is, okay? So these are two same roots, you could say, or one distinct root. There are many ways you can say it. One distinct root, blah, 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 blah. But they're actually two roots. Both of them are negative b over 2a, so they're repeated. For example, you have x plus 3 over square, x plus 3 squared. It's x squared plus 6x plus 9. You know about these, right? So in that, negative 3, x equals to negative 3 is a root, but that's the only root. But quadratic should always have two roots. So negative 3 is a repeated root. They're repeated roots. Okay, they're repeated roots. By the way, if you're wondering for repeated roots, how will we draw it in this quadratic? Oops. Sorry about that. If you're wondering for this repeated roots, how will we draw this in the quadratic inequality diagram? Simple. It'll be something like this. This intersects it only once, okay? That's how it's going to be. Now, there's one more case where b square minus 4ac is positive. So it'll be negative b plus minus root b square minus 4ac over 2a. If this is positive, let's say it's something called some positive value x, it becomes negative b plus or minus x over 2a, where x is a number we know. It could be positive 5, positive 10, positive 15, positive only, okay? Because it's square root of something positive, okay? Then we'll have two distinct roots. This time it will be distinct because one time it's b plus x over 2a, one time it's minus b plus x over 2a, one time it's minus b minus x over 2a. So this will be two distinct roots. In this case, it was one distinct root or two same roots. Okay, and in b square minus 4ac lesser than 0, it was no real roots. Okay, so in many cases they'll be giving you questions and you'll have to tell whether the roots are real, not real, blah 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 blah. For example, they might give you an equation. Suppose it's a quadratic, okay, and they say that a linear graph is a tangent to the curve. They might tell you that the linear graph is a tangent to the curve. It means that suppose this quadratic is y is equal to f of x, and this linear is y is equal to g of x. A tangent to the curve. A tangent means that they intersect at one point. I'm not talking about your tangent in trigonometry, okay? I'm talking about tangent in these lines. A tangent means they intersect at one point. Now, from simultaneous equations, you should know if two graphs intersect, you make them equal. fx equals to gx. This is your year 9, year 8 stuff, but just in case you are not sure why, I'll try to give you a logical sense of it. If two graphs intersect, their x value is the same and their y value is the same. So at that point, their coordinate is the same. Their x value is the same, their y value is the same. So since their y value is the same, you make y equals to y. So it becomes fx equals to gx because, hello, y is fx and y is gx. Because if they intersect, their x coordinate is the same, their y coordinate is the same. If here the y coordinate is given as fx and here their y coordinate is given as gx, and they are saying that at the intersection they're the same, that means fx equals to gx. Then you find the x coordinate which they're the same, then you can find the y coordinate which they're the same. Now, the thing is sometimes one of the coordinates, it can be given in terms of letters. For example, it can be given in terms of k. K is the favorite letter which they like to use in the exams. So let me actually give you guys an example, and then we can end it here. Okay, so we have a quadratic which is x square minus 4x plus 7. So y is equal to x square minus 4x plus 7, and we have a linear which is y is equal to mx plus 6. And they said that this is a tangent. This is a tangent to this graph. Means something like this, they intersect at one point. intersect at one point, and they're asking us find the possible values of m. What do you mean possible values of m? Now see, here's the thing. For it to be a tangent, it can be a tangent like this, so like this, 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 like this. It can't be a tangent like this. It can't be a tangent like this. It needs to touch, or it can't be a tangent like this because it's touching at 2 points. So at some values of m, because m decides if the graph will be like this, like this, like this, or if it will be a tangent like this, or like this, right? M decides that. So only some values of m can give you a tangent. So the first thing is, you know that when they are when they intersect, the y coordinates are the same. So you can first equate them. X squared minus 4x plus 7 equals to mx plus 6. So because these functions are in terms of x, you are actually finding the x coordinate of this point. You're finding the x coordinate of this point. And we are saying that the x coordinate of this point is a solution to this equation. The x coordinate of this point is a solution to this equation. So let's bring it in our nice little quadratic form, which we like. I'll be a little bit quick because we need to respect time also. So the x coordinate or coordinates, in this case, it's only one coordinate. So that's why I'll say the x coordinate of this point is actually the solutions of this point. But we want to make sure it's a tangent. It's a tangent. It's not like this, or it's not like this. It's a tangent. So it needs to have only one coordinate. It needs to have only one root or one repeated root. It's a quadratic, so it'll have one repeated root. So we need to make sure this is just one repeated root. So we'll need to make sure b squared minus 4ac is equal to 0. And what's a, what's b, what's c? Remember, this is how it works. Ax squared plus bx plus c equals to 0. So b will be minus 4 minus m. Then minus 4ac. A will be 1. The coefficient of a is, this is 1x squared. Then c will be 1 also, which is equal to 0. Okay. Then you can solve for m. Okay. Sometimes you will need to make, sometimes you might need to make b squared minus 4ac greater than 0. And if you get a quadratic and this is greater than 0, then you might need quadratic inequality here. Or sometimes if you need to make the discriminant lesser than 0 and you get a quadratic, again you'll need quadratic inequality. Again, you need quadratic inequality. Okay, so I hope that was helpful, and I hope I covered all the concepts of this chapter for you. Okay, if you have any questions, then please ask me in the comments. I'll be sure to read your comments. And yeah, that's it. Okay, so do practice some past year papers on this or some questions in your book. This is not a very difficult chapter. All this should be free marks because these are one of the easiest chapters in Add Maths, provided that you don't make any silly mistakes. Okay, so provided that you don't make this mistake which I told you. Okay, don't make this mistake. Let me highlight it in red just so that you guys don't make this mistake. Don't make this mistake. Okay, and be careful that in inequality the sign negates, the sign reverses. Okay, so all these facts, little facts, be careful about them. Okay, solve as many questions as you can. Try to understand this properly. Okay, I feel I've done a fine job in explaining it. If you don't understand it, please watch it again. The point is this needs to have one intersection. You find this intersection using this equation. If it needs to have only one solution, means the discriminant needs to be 0. Because if the discriminant is 0, this becomes minus b plus or minus. This looks like an inequality sign. This plus or minus 0 becomes minus b over 2a if the discriminant is 0. Okay, one very last important thing I want to mention. Sometimes, so we know if it's lesser than 0, it's no real roots. If it's equal to 0, it's one distinct root. And if it's greater than 0, it's 2 distinct roots. Now, one time in the exam, in I think IGCSE May 2022 series, they asked a question. It has real roots. It hasn't told you if it's, of course, it's quadratic, okay? But it hasn't told you if it's, so it has 2 roots. It's quadratic. It has 2 roots. But it hasn't told you if it's distinct or not. It just said it has 2 real roots. 2 real roots here. If b squared minus 4ac equals 0 or greater than 0, both give you 2 real roots. It's just that in one of them, the real roots are the same. In one of them, they are different. So one time the question just gave 2 real roots. So what do we do with the discriminant? We make it greater or equals to 0. Because we don't know. It could have been that 2 roots are the same. It could have been that they're not. So we take both cases. It's either equals to 0 or greater than 0. So greater or equal to 0. Because remember, if the discriminant is 0, it's still 2 real roots. It's just that they're repeated. So if the question says they have 2 real roots, you might want to put greater or equal to 0 on your discriminant. Okay. So that's it for this chapter. Okay. I think I did a better job in the time limit this time. 36 minutes has been, it will probably be 37. The last one was 48 minutes. So yeah, I hope I answered, I hope I cleared many doubts, and I hope this was good revision for each and every one of you. And if you're learning this for the first time, then I hope you learned something new. You cleared all your doubts in this. Okay. If there are any questions, please let me know in the comment section. And yes, this is the second chapter in my book. Don't worry. If you have a different book, don't worry. I'll be covering every chapter eventually. I will be covering every chapter eventually. Okay. Don't worry about that. That's my duty. I'll be covering every chapter eventually, and we'll discuss it in the best way. Very fun, very short, crisp. Okay. You can watch it in 1.5x speed with a coffee, with a tea, or just with full focus. Okay. It takes 25 to 30 minutes if you watch it in 1.5 times speed with full focus to completely clear a chapter out, which I think is a good time investment. Okay. So I'm speaking too much. Let's end this right here. I'll see you guys in the next video. Okay. Until then, take care. Okay. Keep studying hard. If any question, just ask me. Keep studying hard. Keep enjoying, because life is more than just studying, but study also. Okay. Oh, Shamat, you're very, very inspirational. No. Enjoy. Okay. Enjoy your studying. Okay. Chill out. Enjoy. Take care. Peace.